I know in biology, for some reason, green is actually very hard to achieve with microbial dyes. But I forgot to go in one weekend to remove the bacteria from the incubator. On Monday, we realized that it had turned green.
Hey, Ram, how you doing?
I'm doing great, Carl. Wow, holidays are in full swing. How are you?
Well, welcome to the Grow Everything podcast, where we talk about biology as technology. And I think the holidays have been going really well, to be honest. I mean, we just got snow in New York City, which is a treat. And this weekend, I drove up to Saratoga County and back to go check on my father-in-law who just had surgery. And he's recovering well, but there was about 4 inches of snow on the ground up there. And, in addition to his recovery, we've been super busy. We had a holiday party last week. We're attending holiday parties and we're kind of in this mad sprint to close out the year with our clients. What do you have going on? What do you do this weekend, Iram?
Yes, that snow was very beautiful. It was like the perfect type of snow where it had the right texture. It was soft enough to be able to cover all the trees. And so it was definitely a winter wonderland here in Brooklyn. And we actually walked through the Brooklyn Botanical Gardens. And it was like, I couldn't believe it. I was like, am I in Colorado? Like, what's going on here? Like, it's so amazing. And I just spent my husband, my son, and I spent the whole day just walking around Brooklyn in our neighborhood. And I mean, we're lucky to live in an area that has such beautiful spaces, like the botanical gardens, like the museum, just even the streets, Eastern Parkway, looking up and down. It was just beautiful.
We were driving down FDR on the east side of Manhattan. And to me, it was like the perfect encapsulation of snow in New York City, because on the one hand, you have the trees that are covered in snow and they're so beautiful. And then you look next to you on the concrete wall and the snow's already like all turned gray and brown and black. And so that's what's going to happen to the snow. Unfortunately, like the snow in New York City to me is always very beautiful the first day. And then it starts to turn gray on the streets. And then you remember, oh yeah, we live in the city.
Yeah.
And luckily the parks don't get that. So the park can last for many days and really be so beautiful. But it's always a treat to get snow before the holidays and during the holidays. So I was very excited and I'm so grateful.
As long as it still happens, right? The current trajectory, how many more snow days do we have? So definitely cleared out my schedule once it was snowy. We all went outside, had, the snowball fights. Didn't have a sled, but it was fine. I mean, I should have picked one up, but we had a great time anyway. But yeah, for the rest of the year, we are slammed just to wrap everything up in a nice bow so we can relax during the holidays. And during the holidays, I know you do this and I do this too, is that it's good to have something to think deeply about. You have days where you're not just grinding away on meetings, delivering, but to be able to have the space to go deep into a certain topic. And whether that's inspired by, of course, our conversations here on the podcast, but, you and I love to read and, watch different shows. And let's talk about that, because I have been in this rabbit hole since we had an amazing conversation with Mike Levin around the Thanksgiving holiday. Our conversation with Mike Levin was really about the essence of consciousness and its pervasiveness from not only our perspective as humans, but how the agency of living tissues and cells and organs all have a type of agency, and it differs and it responds to its environment. And it could be a chemical thing, which, Mike Levin talked about electroceuticals. So if you are like, what the hell are you talking about, Iram? Go back to that episode and listen to it. But that conversation kicked off this whole exploration for me. And I was reading Mountain and the Sea, which is also about decentralized consciousness and animals being able to have higher forms of intelligence like octopus. And now, after I finished reading it, I gave it to you.
Yeah, and I had read it when it first came out, and I'm super enjoying it because, again, Mountain and the Sea is about octopus consciousness and people who are studying that. And it was very widely praised when it came out just a few years ago. I remember very much enjoying it, and so I'm enjoying it again. And after this series that we just did last week, where we talked about fungi, I really started thinking about Mike and whether he and his team have ever made xenobots from fungal cells. So it's just like, again, really thinking about consciousness in a different way. I don't think I'm thinking about it as deeply as you. I've been watching a lot of movies too and just looking for little signals of biotech in movies or nature in movies. I watched a movie called The Outrun, and at the end of it, the main character was talking about getting a PhD in seaweed because she's in the Orkneys, which is the islands off the coast of Scotland. And she talks about the seaweed industry, which is something that with the exception of Julia from Sway, it's not something we've talked about very much, but there is an industry that has a lot of longevity that is built around seaweed. But anyway,
yeah,
I digress.
No, I mean, this idea of being inspired by different sci-fi movies and books and shows, that's where a lot of inspiration and new ideas can come from, because biology has a lot of capability and potential. And we're just scratching the surface when we know how to use it. And so, we mentioned reading Mountain and the Sea as we're talking to Michael Levin, but I was also watching Stranger Things, the season finale. So there was a lot of ideas that I started coming up with or just thinking about deeply. And now I'm reading Dawn by Octavia Butler. And I'm so regret that I haven't read Octavia Butler until now. I'm in my 40s. I feel like that would have changed a lot of my perspective if I read it as a younger person. But it is very interesting about if alien life and human life interacted, what would that look like? How does alien life look differently? How do they act differently compared to humans? How do they perceive humans in terms of human strength and human flaw? And then my book show pairing is Pluribus, which is on Apple TV. And I know you're ahead of me when it comes to that show, but wow, talking about biology and intelligence, I can't wait to go my rabbit hole and just go under my covers and just think.
Yeah. Yeah. I mean, Pluribus is an incredible show. It's by the same creator as Breaking Bad and Better Call Saul. I think Vince Gilligan is at the height of his powers. Pluribus is an incredible story. And I will just spoil the beginning by saying it does involve biology. So.
Yes. Yeah. And consciousness. And collective consciousness.
And as the story evolves, you might forget how this whole thing got triggered, but it definitely has to do with biology. So I can't recommend it enough. I think it's an incredible story.
Okay, yeah. Well, so homework for listeners. You have to watch that show. It's on Apple TV. So if you don't subscribe to Apple, go to a friend's house or figure it out, or just subscribe just to watch that and unsubscribe. Do what you have to do. Apple's not sponsoring us, unfortunately. Otherwise, we would say stay subscribed. But yeah, and I think this is this is about, fundamental use of biology and how it can work, the potential and the capability. And of course, we talked to Mike Levin and others about how biology can make materials. And that's what today's episode is about, is using biology to make unique materials that you may not think to use biology to make.
Yeah, exactly. I mean, materials touch every part of our lives all day long. If you're wearing clothes, which I hope you are, those clothes are made of materials, whether they're sourced from natural sources like cotton or wool, or polyester, which is man-made from oil. These things are materials. And what's interesting, at least to me, it's interesting, is we spent time talking about biomaterials a fair amount here on the podcast. And we know that the material sector overall has been performing poorly. Mining has been in the news a lot because of the interest in rare earth metals and kind of geopolitical issues with that. Other minerals have been in the, like lithium and cobalt have also been in the news because those are very important for the green transition. But other areas where materials have not really done well are like in chemical and agriculture or construction materials that have been challenged by geopolitics. Today's guest is someone that I saw, or at least I saw their material at an art exhibit at BioBat many years ago, and I ended up blogging about it on LinkedIn. And then I ended up meeting Aradhita at the Biomaterials Biocouture event that was held, I believe, in October at Indie Bio. Erum, was that the first time you had met Aradhita?
Yes, that was the first time I met her. And, I was talking to a bunch of people and you came up to me you have to meet her, go see what she's doing. And I, she had a table of different materials that she's made. And what Aradhita makes is embellishments, which we'll get into. And I was like, this isn't made with biology. What are you talking about? Because it looked so good. And it looked like it was plastic, but it wasn't. It's just like, okay, yeah, we need to get you in the pod ASAP. And here we are.
So just so that people understand what embellishments are, when you look at a piece of clothes, it could be embellishment is even something like a zipper, but the embellishments that Aradhita makes through her company Cellsense are things like sequins and beads. And the reason I was very touched by this story or by her story was because it's one of these things I don't really think about. But then when you look around and you see that other people have beads or sequins on their clothing, someone has to do that. And it's done mostly by hand. And many of those materials are produced through petrochemicals. So a lot of people who are producing these things or manufacturing them are breathing these things all day long. So they're not in these businesses for very long because these things end up affecting their health. So, Erum, before we introduce Aradhita, why don't you talk a little bit about her background?
Yes. So Aradhita is a materials designer from India. She's based in New York City, actually right in Brooklyn. So we're very lucky to have her close by. And her company, Cellsense, addresses microplastic pollution. As you mentioned, it's very problematic the way that these embellishments, whether buttons or beads or sequins, are made. Aradhita has a master's in textiles and a bachelor's in fashion design from Parsons School of Design. So she's been thinking about this very deeply. And she has 5 years of experience in material science and sustainable design. She was a materials and colors researcher at Slow Factory Labs. And she also was an embellishments designer at Tory Burch. So she has a lot of great experience working with different brands and has successful pilots, raised venture capital. She's been recognized by Forbes 30 Under 30. She's a perfect person to speak with about how we can make biomaterials cool, sexy, beautiful, that we're very proud to wear. So let's let Aradhita take it away. Hi there. I'm chiming in quick because it turns out that our guest audio cuts out a little bit throughout the show. It's a great episode with all of the insights and inspiration that you've come to love about this podcast, but we just wanted to give you a heads up. Enjoy the show.
Aradhita of Cellsense, we are so happy to have you on the Grow Everything podcast.
We're very excited to be here. Big fan of the podcast. So thank you guys for having me on.
So you're another Brooklyn person. So those of you who can't tell from Aradhita's accent, she is actually from Brooklyn. And your journey started from textile factory visits in Gujarat in India to founding Cellsense, which is amazing. What was the catalyst that took you from being a designer of embellishments to a material scientist working with algae and bacteria?
Right. So growing up in Gujarat and visiting these factories, being in contact with craftsmen, where I saw the human impact of fashion's textile dyeing system long before I understood the environmental one. And working for fashion houses in New York City, I felt like there was often a disconnect between design and production, and materials were superficially accepted as sustainable, yet they tended to have a major negative downstream effect. And my motivation was really to develop a genuinely sustainable yet scalable solution. I was very interested in dyes in the beginning, and I was looking at natural dyes as a source of replacement that were plant-based. But then studying it a bit more, realized how resource intensive the system was, how much human labor, fertilizers, fuel for transportation. And even though it's better for the human body and for producers, it's not that much more sustainable as a system. I was really intrigued by the potential of bacteria to have vivid color and fluorescent properties. So that was really the catalyst for what made me interested in biotech. But to answer the embellishment parts of the question, people often think of it as like a niche solution and don't realize that the fashion industry is worth about $1.8 trillion. And 1 in 5 garments that are produced annually contain embellishments. So it is a pretty big industry. And a lot of European brands are facing regulatory pressure. In 2027, the EU is going to ban microbeads and lead, which is going to severely impact both exfoliants as well as embellishments. And so I saw this big demand. I was working as an embellishment designer at Tory Burch, and we were talking to over 900 fashion brands headquartered in New York City, and realized just how many were looking for this solution, but were lacking anything viable that was sustainable and could replace plastic. So it wasn't the lack of motivation, it was just the lack of existing solution.
Can you, for our listeners, explain what embellishments are? I think a lot of people don't know what that means.
Yeah, definitely. So embellishments would be things like beads or sequins, as well as trims would include hardware like buttons or zippers as well.
Okay, cool. Yeah. I wasn't sure if it included zippers and buttons, but I'm glad you clarified that because I was like, oh, 1 in 5. I'm like, because in my mind it was just sequence. I'm like, 1 in 5 garments have sequences on them. I'm like, definitely, I know in some parts of the world that would be the case, but yes, it was buttons and zippers for sure. Okay. That really helped kind of frame the world in which you're living. And so before I get into this next question, I wanted to know a little bit more like, you saw the problem and how did you get introduced to the idea of using biology as a solution to make embellishments? Was there a class you took, a person you met? I'd love to know a little bit more about that. Like, what was that light bulb moment?
Yeah, so I had spent some time with the dye fixation, developed like a thesis around that, and got a regular 9 to 5 and went to work in the industry. But I did have some synthetic biology experience and curiosity. And with sustainable solutions, the only replacement I found in the market were, for instance, plastic sequins or recycled plastic sequins, but they themselves act as a source of plastic waste upon disposal, right? So they're only so sustainable, and the colors are pretty like black or very lacking in like the vivid color profiles that design brands generally would want. The other solution was wooden beads, but they would sometimes look crafty. And so I started as a passion project working with algae for its base properties such as hydrophobic properties, antimicrobial properties, and I combined it with cellulose, which is one of the most abundant organic materials on the planet. We source it from textile waste as well, and it has excellent color retention. So we know color especially was of utmost importance to the brands. So it started off with me just like playing around with these materials. When I first brought it to the brand, they said it sucked. And they told me that they wanted to see the vivid colors, they wanted to see a smooth finish, and they wanted to see iridescence. Without that, no one would use it. And it just became like a back and forth where I was getting active feedback from the designers at Tory Burch who were telling me how to iterate the product. And then it got to a point when it became something that could be commercially viable.
Wow. Wow. I love that. I love the fact that you are talking to, a customer, like the end user, the industry, and you're iterating along with them to really hone in on what type of specifications they're looking for versus being in your lab or in your office, just doing it yourself and making assumptions. So this is a wonderful, I think, lesson I just want to point out because Karl and I were talking about this earlier about just getting out there and talking to people first and doing it as soon as possible because time is money, right? And then again, this combination of using cellulose and bacterial dyes. But is it purely biology product or are you combining it with other types of materials? What does it look like in your daily work in terms of how your products are being made? Is it like fermentation? Tell us a little bit more about that.
Right, that's a good question. So we create our base polymer. It's made in-house, so we don't use like industrial PHA, PLAs, for instance. One of the unique properties of our biopolymer is that it can set at room temperature. So you don't really need machinery that you would need for like thermosets that require about 1,000 degrees Celsius. You can make materials at room temperature. We can directly deposit it on fabric to create beaded fabrics without any manual labor. And that makes it cost competitive with plastics because we're eliminating the most cost intensive part of the process and significantly simplifying the supply chain. And that is only possible because of our biopolymer, which we create in-house. It's 100% bio-based, so it's all algae and cellulose and some other sort of materials that we use that are also, for instance, we use natural cross-linkers instead of synthetic cross-linkers. We were inspired by people often think that bio-based materials will fall apart or they're fragile, but they don't realize that wood or wool are also in a way like bio-based, right? They can survive natural wear and tear, yet they safely compost. And similarly, we've tried to recreate their structure by using natural cross-linkers, as a result of which we've created pretty durable materials. We did a skincare pilot recently with FKA Heckles, for whom we created these exfoliating pads that you can use in high moisture environment. And then with the fermentation side of it, our dyes are the ones that are more conventionally like fermented, and then we extract the pigment from the bacteria. And all of our material is solution dyed. So with plastic beads, for instance, they're dyed in a leaded coating, and that often chips and leads to poor appearance over time. Whereas because our material is solution dyed, it retains the color pretty well and doesn't chip or isn't prone to poor appearance with wear and tear.
So before I ask the next question, I have a question. What does that mean, solution dyed? It means that like the dye is actually put into the solution that you produce the beads from. Is that correct?
Yeah, you're spot on. So it essentially means that the biopolymer itself is dyed with a pigment. Usually it's post-processing where they're coated on with like a colorant.
Got it. And then before we get any deeper into it, I'd love to, there's two things I kind of want to describe. For someone who hasn't been around the fashion industry, I'm not someone who has been, but I have done a lot of walking in like the 30s of Manhattan where the fashion industry is centered. So a lot of times if you're doing that and if you're paying attention, you can walk by stores that are just like, hey, this store sells beads. Hey, this store sells buttons. Hey, this store only still sells zippers. And like, those are the kinds of places I think where your product either is or will end up. And it's really amazing that there are still these people. Of course, there are these places that are only selling like one little piece of the bigger pie that is fashion. But give us a sense in terms of like, what does it feel like when you're looking at or touching one of your bio embellishments? If someone was wearing it or if someone saw it, what would they see?
They feel quite delicate, yet they're sturdy. Like a lot of people, when they touch them, they're like, oh, we don't want to break them. And then I encourage them to try. And they're often taken aback by how durable they feel. They have, I would say it's closer to like glass in appearance, where it's 3D and transparent, but it's quite lightweight, almost like a plastic. If you drop it, it has like a similar clinking sound to glass, and the surface finish highly varies. Our material is very customizable, so we can 3D print molds and create a finished prototype in a day. So you could get like a faceted surface finish, or you could get a very smooth spherical surface finish. And yeah, that can differ at times.
Yeah.
Amazing.
Yeah, I remember. So, we met at the Bio Couture event, and that was co-hosted by Biofabricate and Juniper VC at Indie Bio. And you were showing some of your beads, and Karl had met you first, and he's like, "Oh, you should go meet Aradhita." And I was
I didn't say it that way.
Okay.
Or maybe I did.
Aradhita. Okay, that's how you said it. So then I was looking at it, I'm like, wait, these are made with cellulose? Because they looked exactly like beads that you would see. Like, it just felt like earlier you're talking about vibrancy and you talked about glass, and it was incredible. And it was actually the same day we met Gabe Tavas, who we interviewed a couple episodes ago, where he's making wood out of bacterial cellulose. I've been constantly blown away by founders like yourselves who have been using biology to make just really like hyper realistic and even better than what already exists. So it's like not that you're settling for something that's like, sustainably made or bio made. It's actually even better sometimes, which is beautiful.
Thank you. I appreciate you saying that. It took us a lot of time and effort to get it to have the appearance it does. And yeah, that was like a big motivation for me, was to understand biology in a way that we created not only like lower value replacements, but enhancements, like with our fluorescence or with automated production. Realizing how it can surpass the capabilities of plastics was a big motivation.
Yeah. So let's talk about that a little bit, right? So I know it's a lot of work to work with biology. So there must have been like unpredictable moments, things that went awry that you learned and you pivoted. Can you tell us some of the surprising moments that helped you down this path of creating these really beautiful embellishments?
Yeah, the quality control is always an issue with biology at times. And for us, that really involves studying the organism, what it naturally wanted to do, and recreating that patterns in a consistent way over and over. That's how we've been able to get a lot of our dyes. I know in biology, for some reason, green is actually very hard to achieve with microbial dyes. But if we would incubate it for a longer period of time, and what that meant is I forgot to go in one weekend to remove the bacteria from the incubator. On Monday, we realized that it had turned green. And we were like, oh, that's so interesting. If we just leave it for a longer period of time, it can actually have this property that would be very difficult for us to engineer otherwise. So learning from mistakes like that has helped as well.
But, you know, on the other side of it, you're a designer. And so you're probably used to controlling outcomes and aesthetics. You need to have this uniformity. And yet, when you work with microorganisms, you have to enable this type of agency in the material. How do you navigate the tension between control and collaboration with biology?
Yeah, I think both skill sets have been useful for me, like having the sense of how a regular designer would want to work with this material where they can have predictable outcomes and some control. And I myself would want that as well. So developing processes with which we can achieve that, but also just being very patient. And we had like a time lapse camera, and it was so cool to just see the organism acquire color over time. And I think we just started to appreciate what biology could do, and that resulted in me, who can normally be impatient, developing patience, and then studying it and recreating it over and over to have a perfect result over and over that designers can rely on.
Yeah, yeah, I love that. Let the biology take the wheel and see what happens. And I love how you forgot about the project or the material being made and it turned green. It's just like, okay, the secret here to get the green was time and the
Yeah,
patience.
it's amazing.
I just love those types of stories. But so Cellsense as a company, it's not just about materials, it's about creating a circular system. So tell us the hardest part about building this ecosystem where you're creating, this company that's making this replacement for business as usual embellishments, and you're talking to some of these brands, but tell us what's been the hardest part about this.
Yeah, I think, what a lot of sustainable material companies probably have to deal with is just the price expectancy, right? The industry is used to a certain price point, but sustainable materials are often higher, and products are limited to like boutique solutions. And that was something that we really wanted to overcome. And what brands love most about Cellsense now is that we're not just a material replacement, but a smarter, leaner supply chain. We're simplifying production. They would have to source the beads, they would have to create tech packs, then they would get beaded fabrics, often with a long timeline. And we're creating it in one go. Our robotic syringes can create the beads and beaded fabric in a single integrated step. So this means it's resource efficient for them. Fashion is a very trend-based industry that changes quickly. And so they want something that can be produced with a lower lead time. Our lead time, for instance, is about a day versus with conventional systems, it takes over a week to make a yard of complex beaded fabric. So we have significantly simplified that, and our program can pixelate the images brands send us. So we create the file, it's like a file to fabric system. We are able to create the beaded patterns for them. We're able to create the beads for them, and we're able to deposit the beads directly on fabric for them. And that is really the value add we provide. And with this system, we can compete with plastics on price and beat them on lead time. So it has really been one where we've talked to the industry a lot. We've figured out what the challenges are, and we've figured out what unique value proposition we can provide that would help them get over some of the humps that normally come with adopting sustainable materials.
That's amazing. And I mean, you guys are also creating materials that glow, that are bioluminescence, that potentially can either absorb carbon, can decompose rapidly, and really challenge what's conventional in fashion, which is supposed to be like this leading edge industry. But what feature of your materials do you believe in is the most powerful or most underappreciated, and why?
Yeah, what I love most is just the ability to customize the material for anyone who's dealt with injection molding, right? You're familiar with the MOQs, the long lead times, the high price point. And with us, if a brand is like has this unique idea of a unique form they want to create that's never existed before, they can send us a CAD file, we can 3D print molds, and then we can show them a finished prototype. And just the speed that allocates and the ability to achieve unconventional shapes that you haven't seen with a plastic or a glass is something that's really exciting to me. And the fluorescence is something that I think I did for fun when trying to create a sample. And it kind of was the thing that made Cellsense a little bit viral. It got a lot of brands interested. And it was cool to see how if you create a material that doesn't just mimic the qualities of conventional materials, but provides something like unique in appearance, how so many people are instantly excited about it.
That's amazing.
Yeah, I would love to see that. I mean, is that something that you kind of just prototyped and played around with, or is that in production? And like, because I have dinoflagellates that bioluminesce, and that it's according to like their circadian rhythm, and it only happens at nighttime. So I would love to know a little bit more about it because I love bioluminescence. And when people are talking to me like, oh, what kind of applications can you make with biology? And I always try to tell them like, oh, you can make things that bioluminesce. And I think it's one of the most beautiful things that nature can offer. But tell us a little bit more about that. I'm really excited about it.
Definitely. So that has been one where we can't always predict the result consistently. And so we have to put that into production at a bigger scale. But for the piece we made that went viral, that was when I was still working a 9 to 5 job and was kind of making some progress with this project. It wasn't even a company at that point, and started creating this garment as a passion project. And I had these like secret images and things that you would only be able to see once it would express its fluorescence. And it's sort of similar to charging a battery, like you would have to expose it to UV light and then it would glow. I made that about 3 years ago and it's still glowing, which has been very
That's amazing.
Yeah.
Yes, I like that. Still glowing. Keep glowing.
Listen, we've been talking for a long time about working with the people who come on this podcast and having a store. We need to get together and collaborate and do like a limited edition of a Cellsense messaging lab branded something. Erum, we need to put our thinking hats on and we need to go to the factory and industry city to see what we can do together.
Yes. All right. Let's do it. Okay, here we go. We're brainstorming. This is how it happens, everybody.
You started off by talking about like the human component of design. And this is what you and I talked about when I first was exposed to your material at BioBat. And then when we met at BioFab here in New York a couple of weeks ago, we talked about like the human element, which really struck me. This is the kinds of things that people don't think about, like who are the people that are putting the beads onto garments? Who are the people that are adding the buttons? Like a lot of this stuff is still done manually. But what's the impact of having a bio-based material for them? And what has been the response?
Yeah, definitely. That was one of the biggest motivators for us. I mentioned that I grew up in Gujarat, which is one of the biggest textile production hubs. The impact you see on the labor that works in these factories is mind-blowing. Like, it's a well-known fact that the dye master dies of a heart attack every 3 to 5 years because the chemicals they deal with on a daily basis are just that toxic. And it's also just fascinating to understand that we are wearing that chemical against our skin 24/7. There is so much about eating organic food, but not really about wearing organic or healthy materials. And the impact for like right now, 60% of the workforce that is involved in the embellishment industry comprises of women and children. And a majority of them have been documented to develop health issues, whether that's cancers because of exposure to carcinogens like lead is commonly used in plastic beads, for instance, or they develop vision loss as well as carpal tunnel because of the constant repetitive hand movements. And it is just incredible, and that there isn't many ways to automate it yet. So the industry almost exclusively relies on cheap manual labor from overseas to attach these embellishments or beaded like buttons, trims to garments. And for us, we are trying to upskill the very same craftsmen, but trying to use their ability, like their creativity, or they're very good at quality check for us. They know what the material needs to have, like how sturdy it needs to be, what the strength resistance needs to be, or the appearance, and they can constantly give us feedback. So they would, for instance, still we have these machines like similar to Opentrons that have robotic syringes that can directly deposit beads on fabric, but the pipettes can clog if no one is looking at them, and that would create issues. So we still need like technicians to help us with the process, but it isn't as manual, for instance. And so we're trying to upskill the same laborers. It's been amazing how many factories have reached out to us that do embroidery who wanted to license everywhere from India to China to New York. Again, we're like a young startup that hasn't advertised or marketed ourselves as much. Yet these very niche factories have been reaching out, wanting to license our technology and wanting better for their own craftspeople. But there simply isn't a solution that exists that they can adopt, and they're often painted as like problem, and that is just not true.
Yeah. Yeah. And it seems like these factories with these laborers are servicing like the fast fashion, the everyday fashion industry versus the luxury niche space, right? Where you have like someone graduating from FIT, or the Fashion Institute of Technology, and like they're helping like Balenciaga develop a dress for the Met Gala, right? There's like this difference between the volume of embellishments that are being made and used. You aspire to work with these large factories so that they can use not only embellishments, but the technology and the automation. Tell us a little bit more about what does that look like and where do you start, right? Like just to paint the picture for us, because I would love to know the plan to can it scale up was one question I'm asking here. And then also like, which type of garment have your embellishments been on the most, right? Are they on dresses? Or are they on pants? I'm just curious.
Right. Yeah. So we thankfully closed our pre-seed round recently.
Hey, congratulations.
Congratulations. That's great.
Right. Yeah. With that, we now have the funding to be able to scale. We're looking for engineers to join the team. So shout out if any engineers are listening to the podcast, please feel free to reach out. We have already who are helping us with the automation and making the technology as simple and versatile as possible. We're not trying to reinvent the wheel or create completely new machinery. We're trying to use existing ones and make them work for our process. For a factory, for instance, it would look like something like they would buy the hardware or the capex to set up our machinery, and it's significantly lower than like conventional capex. So that would be the first step. And then we would provide biopolymers on a subscription basis so that they're able to create whatever materials or garments they need. And for the second part of the question on what the material has been used so far, we've completed 4 paid B2B pilots. So again, what you mentioned earlier, Erum, it was very important for us to move out of the lab and talk to the industry, get feedback, get our material in the hands of end customers. We were very against doing any collaborations that were just for marketing purposes that wouldn't be available to end customers. So all 4 of our pilots have been available to people so far. We've done one in fashion with a New York-based designer, Ian Allen Greer, who exclusively uses dead stock fabric. Our second collaboration with is Roma Narsingani, who's a Mumbai-based jewelry designer. We collaborated to create an initial collection which sold out, and then she's placed 7 reorders since the initial pilot. That has been great validation for us. Then we worked with NPOM, a seed bead jewelry brand that creates these like really intricate chokers and different necklaces with the beads. And that was our largest order of about 50,000 beads. And most recently, we worked with a mid-range skincare brand based in the UK, FKA Heckles, who used our material in the form of exfoliating pads as a replacement to microplastic like beads, as well as cotton pads. These can be used for over 5 years, and they did third-party testing to ensure the material's performance and durability in harsh environment for months continuously, and found that we were one of the only sustainable solutions that met their performance standards.
Yeah. Is that what you were holding up earlier, that material that you printed out? Is that the pad?
It's like a version of this. It's a small version of this that goes on your finger. And you can kind of use it.
That's amazing. So looking ahead, either near term or long term, what kind of scientific discoveries or tech tools are you most excited about that you think you would apply in your work? Something that you feel is going to transform sustainable materials in the next decade?
Yeah, I know people have become like sick about hearing of AI.
We're not.
Material discovery platforms or tools like Radical AI is an interesting company based out of Midtown, New York. Yeah, and they make these computational tools with which you can access a biopolymer structure and feasibility before you do all the R&D or get all the materials and test for yourself. And I'm curious to use something like that in the future and see how helpful it can be in the whole material development process.
Wow. Yeah, I love it. I mean, if you don't have an AI strategy, you don't have a company. So there you go. Great. That's great that you're thinking about it like that. So then kind of continuing in that frame of thought, you just raised some funding, but what if you had unlimited resources and no technical constraints? So what would your dream project be at Cellsense? What radical design material system would you build if anything were possible?
Right, that's a good question and something I daydream about. And I would say that I love how versatile the material is, as I touched on before. It can be molded into any shape ranging between 2 millimeters to 8 inches. And we only looked at embellishments as the first sort of application. That was an industry I was familiar with and I saw a need in. But I think it has a range of applications across industries to replace small format plastics. So my dream would be to create almost like a website that a customer or a brand could log into, upload their design, and receive a bioplastic or biomade solution as like a drop-in solution within a very limited time frame to any small format plastics that's used across, say, like buttons or bottle caps or different types of packaging. I think this material has the potential to replace all of that.
Wow. Yeah, because I have some garments that I'm like, this could use a little embellishment. And like, I wish I could just take it, like, rather than order it and bring it to my house, I wish I would just like able to go to like a shop, like a Target or something, and like go to a machine and like put my clothing in there and be like, yeah, put these things on it, add a little bit of flair over here and over there. And, boom, like something comes out. But we could daydream about this. I love it.
I love it too. I love the whole like collaboration with the person who's using dead stock materials. That's amazing. So we've reached the part of the podcast where we do some quick fire questions. I'll kick it off by asking you a question. You could answer as long as you like, but we try to keep it moving fast. So what's one material you've never worked on, but secretly wished you could explore?
Probably beauty industry solutions. I would love to work on like face masks or different things like that.
Ooh, nice. All right. We have so much to talk about. All right. So now you're going to put your design hat on. So what's one design rule you'd love to break?
Symmetry or like perfection. I think some of the brands have come up with such kooky designs and I love it. I want to see the material being used in the most unexpected form possible.
I love that. If you could eliminate one material from the fashion industry forever, what would that be?
I might be cheating here, but I feel like I have to say plastic embellishments, right?
Yeah, you do. Good job. Okay. All right. So a non-fashion industry, so outside apparel, textiles, you believe will adopt your materials first.
The beauty industry as well, I feel like they have the most regulatory pressure and a lot of the companies have been willing to work with us and move fast with us already.
Yeah. Oh, this is getting exciting.
What's one common misconception about sustainable fashion or biomaterials that you wish people would stop saying?
Probably just thinking of it as a boutique solution or something that can only serve luxury. With our system and our production method, we can serve everyone from luxury fashion houses to a Zara, and just seeing sustainability as being more versatile or remembering that it's not always like fragile, it won't fall apart. Remember that wood or wool are also natural materials is something I often tell people, and you can recreate chemistry similar to that.
Amazing. Wow. What a great answer. Well, I mean, this has been an incredible conversation. I feel like, first of all, we live close by. We're having some hive mind happening here. So we got to meet up and sketch some stuff out on a napkin. But we don't want to take you away from your global domination of natural embellishments and more in the beauty space. Ooh, exciting.
I just want to say thank you for coming on. It was like when I first saw your materials at Biobat, I was super touched by them. And just having this conversation with you, I just continue to be super impressed and inspired by the work that you're doing. So keep it up. We want to hang out with you and we want to do some work together.
Thank you guys for being so welcoming. It was a fun conversation. And please, anytime you're welcome to Industry City, come by our studios. Would love to brainstorm and keep this going.
Okay, yeah, we'll bring our camera so everyone that's listening can also check it out. Maybe we'll do something like on the ground, grow everything on the ground. Okay, look, we're just brainstorming. Yeah. This is great.
Yeah.
All right, talk to you soon. Hey, this episode is sponsored by Messaging Lab. At Messaging Lab, we translate complex science and economics into compelling business narratives. And we have done so for the most successful biotech-forward companies across pharma, agriculture, personal care and beauty, materials, and the list goes on. We're here to make sure your ideas not only get heard, but resonate with your audience. So if it's time to amplify your company's voice and elevate your business, visit us at messaginglab.com. Let's grow.
Erum, what did you think of that episode?
Aradhita is phenomenal. I mean, her focus for looking at the world of embellishments, which I'm so happy she shared what that is. It's not just sequins. We're not just going to the disco with what she's making. It's buttons, it's zippers, it's everything.
Yeah. I mean, what struck me about the conversation is what I said something at the beginning, where 1 in 5 garments has some kind of embellishment on it. And clearly she really knows what she's talking about. She's really thought about embellishment. She's thought about the impact that they have on the people that are putting these on clothing. And what it reminded me of was something that Susanne Lee said a few months ago, that sustainability is not the lead story. The shift from selling biomaterials on ethical or environmental grounds is not as important these days as selling them on performance, functionality, and new capabilities that they unlock. And Aradhita does that with her company, Cellsense.
Yes, yes. And looking at different types of biology to help make these materials, right? So bacterial cellulose for the beads, looking at algae for dyes. I love that she's open to exploring different biology. I love the fact that she really pushed the limits. She made bioluminescent materials. That's the holy grail, I think, because my sense for Cellsense and other things is that being able to push biology to do things that traditional petrochemistry or traditional materials manufacturing cannot do, and say, yes, this is what biology can do. And to make it bioluminescent, I think is the experience that triple underscores that here's what we can do. And yeah, I guess you can make like fluorescent, black lit things using petrochemistry, but I feel that, bioluminescence is a beautiful thing to experiment with and to see if she continues down the path. We'll let you guys know. But I love that she's thinking of how to use biology in all sorts of ways.
Yeah, no, I would just add one thing, that there's something I want our listeners to understand. One of the nice things about working with biology, if you do it the right ways, you can make this stuff happen at room temperature. You don't have to heat things up. You don't have to cool them off. You don't need that energy input if you've got your biology right. And so Aradhita has these beads and these embellishments that she's making, and she's able to make them at room temperature using biology. That's a huge unlock. It decreases the amount of energy that you need as an input to produce these materials, which are so widely used. And it's another one of the benefits that you get from using biology to produce materials or ingredients. So just thought I would give another shout out to biology as technology, because that is what this podcast is about.
Yes, lots of wins when it comes to using biology as technology. So let's do it. Let's do it safely. Let's do it in a very interesting way. Yes, there's drop-in solutions, but then let's take it a bit further. But thank you so much for Aradhita for joining us. We're going to have her back on as things progress. And we had a great conversation with her, as we do with a lot of our guests. One of the things that we are going to bring back on the Grow Everything podcast, if you've been a longtime listener, you might know that we're doing definitions, where sometimes when we have a conversation with guests, we'll get deep into some topics, and some of them are very niche and you might not know the definitions, and it's not very widely accessible. And we stopped doing them because it tended to be a lot of work. But now that we have more help, we're going to bring it back, and we have an amazing science communicator and associate, Lizette, who will help bring back definitions in the new year. So stay tuned for that.
Yeah, I'm very excited about that. And I'm excited to introduce Lizette to the audience, because Lizette is an integral part of this podcast. She joined us a few months ago, and she's really proven to be an essential part. So having her do the definitions, I think, will be very useful for our future episodes.
Yes, absolutely. Can't wait for Lizette to come on and do some definitions. And you guys, for everyone to say hi to her. But Grow Everything is growing. And we've been doing a lot of work to make sure that we bring the beauty of biology, the capabilities of biology to you. We want to thank people that have been supporting us. We do have a Patreon page, which we'll have in the show notes. We have Tom Baruch, an investor, Beth Tuck, who's a former executive director at GenSpace, who are Patreon members. But we also have a Substack. So if you are into reading Substack and being a participant in that community, please support us. We are really looking to do very exciting things in 2026, where we want to do more live events. We want to do competitions. We want to create some merch. We really want to build out this community for people to learn more about what's going on in the biotech industry and how biology can be applied to every industry. So please consider joining us as a supporter on Substack and also Patreon. Whatever you'd love to do, we'd love to have you as part of our community. It's just like having a cup of coffee with us per month. So we would love it for you to be a part of it. So thank you so much for listening. And is that the pod, Karl?
I think that's the pod. Thank you so much for listening. We'll talk to you soon.